Hey guys, welcome back to the shop. I have you at my desk here in the office, and I want to talk about this next project here that I'm going to be sharing with you on the channel. We have these small shafts. These are, I call them helical geared pinion shafts for one of my customers. And this is actually the third one that we have made for this customer. And I thought that whenever this came up, that this was going to be a great opportunity to finally jump back into some Fusion 360 training and do some practice there, some proper training, and then use that to create this in Fusion and post it out and use our Miltronic CNC machines to get this job done. So this is the shaft right here. This is one that I've already machined, and this is one for my own personal sample. I've got it painted blue on the end just because this one ended up being just slightly under spec on our bearing journals there. Still a good part. You could probably use it, but we ended up giving them 8 good parts, and this one is for my own reference right here. And just what these are, I showed this in a previous video, but this is a new size that we're making there. This is what the shafts actually look like. This is what the factory machines. There was actually a couple of them. So in that first video, we had a straight tooth, this guy here, and we had a helical tooth. All right, and what these guys are they go into servo motors for a CNC machine, and I believe these are like CNC routers. I don't know all the specifics, but I believe they're CNC routers, and this customer uses them to machine foam. Foam that you would find in toolbox drawers, but they have all kind of applications that actually make foam for, or cut the foam. And these little gear shafts right here in the servo motors are no longer available from the manufacturer. So that's why they reached out and asked, would you be interested in helping us machine some of these guys so that we have spares, we can put them on the shelf, and when these gears get damaged, we have a spare, we're not scrambling to try to get the machine back in operation. And I believe what happens is that the gears eventually kind of get the foam material, the dust, I think is abrasive, and it starts wearing the gear. And that's why they want to swap them out. So what they request, this is the third time they wanted 8 of each shaft, so they got plenty on the shelf there. So 2 bearing journals, there's probably some kind of pulley or something that goes in the middle, not quite sure. And then of course you got the gear on the end, all right? So as I said, I've been getting back into our Fusion 360 training. So this is the part here that we designed in Fusion. I'll go ahead and see if I can remember how to rotate it around. This is all kind of like new to me, so I think it's really cool to be able to get in here and use this and move your part around and see it from all angles and inspect it, measure it, make changes, whatever you need to do in order to get your part made. So I want to give a shout out to Kevin at mechanicaladvantage.com, because Kevin is who I am using to help me with Fusion 360 training. That's a service that Kevin provides over there on his website, and I have been working with him for the past couple of weeks now on a couple different projects, but this being the main focus right here. And no matter how minute or small of a project it is, any kind of drawing that you need to do in Fusion is great practice. And there's so many things that you can do with Fusion, and I have only just touched the surface of what you can do with the software. But Kevin seems to really know this software really well. I believe he's been doing CAD for over 20 years, and he really knows Fusion well. So I wanted to show you, I'm gonna drop out of this, and I'm gonna pull up his website right here. This is his website, mechanicaladvantage.com. And the way that he runs his business here is that you can schedule appointments with him by the half hour, 1 hour, I think even 2-hour intervals. And you do it through Zoom, but he also offers other services as well, including on-site services too. So he'll actually go to your facility and work hand in hand with you on your CNC machines and Fusion and that kind of stuff. So if you guys are looking for someone to help you with Fusion 360 training, definitely consider Kevin over mechanicaladvantage.com. And I feel confident that he could really, it don't matter who you are, how much training you got, how much you know, he'll be able to help you out with your Fusion and get you on the path that you need to be. So I'm going to continue working with Kevin. I hope to do this a little bit every week and continue working with more and more projects for our CNC machining. For example, I've got another small part right here that I would like to draw up in Fusion and learn how to machine. Well, I know how to machine it, but learn how to draw it in Fusion and post the process out for our CNC machines to be able to make this. That's a really simple part. It's something for the hardtail vise, and I would like to machine this, but instead of that slot on the end of it, I would actually like to design it so that we have a really nice hex machined in there. So we have some CNC lathe work, which is real simple, and we can set it up in the mill, and do a really cool hex feature on there. So just another one of the little projects, and things like this are really great for our training here with our Fusion 360. So thank you, Kevin, for being such a big help with this. I know Kevin enjoys watching the videos here too. And that's how I learned about his service, is because of, he reached out and said, if you ever need help with some training, contact me, and we can get you some training. So that's what we've been doing. So thank you for that. So we're going to go ahead and go out there to our CNC lathe and begin our lathe work for these shafts right here. I'll show you some of my problems that I had, and trial sessions, and trying to get the software, not the software, but the program working right, and the techniques working right. And then after that, we'll have a separate video on the milling content, and then we'll go over to our Milltronic CNC mill and get our keyways milled in there. Okay? All right, guys, I'm over here on the Milltronics ML16 CNC lathe, working on this next batch of pinion shafts here. Let me show you what I got going on. In the middle of getting the program proven, there was actually a change in the size. So you can see on my print right here, we actually have two different shafts. It's the same shaft, but two different lengths. This is the one that we started with right here. And you can notice the shoulder length right there as being 1.840. Well, that ended up changing, and we ended up having to shorten that up right there to 0.580. There was a wrong dimension taken on the customer's end, and they caught that because I had actually manually machined two of these guys and got them up there quickly because they were hoping to get the machine up in operation very quickly. And they found out that they had taken a wrong measurement and instantly called me and let me know that. Luckily on their end, they're able to take one of them and modify it. They have a lathe there, so they were able to modify it and get the thing working. So I'm working on the batch of 8. And so this guy right here is an example of one that I had already started working on. And I had some problems here. I didn't actually have the chuck tight enough on some of these, and it was actually pushing it back. So that was probably from a number of things. I was using an aggressive feed rate, 15 thousandths per rev. So I've backed that down, and then I may not have had the chuck tight enough too, and it kept pushing back. In addition to that, I was getting a little bit of chatter in there. So what I've been able to do with these first 4 is, since the shaft is now shorter, I just simply parted them off and then remachined them, and these are going to be good parts now. So I'm still able to use the stock because I hadn't turned the other side yet anyway, even though that wouldn't have mattered. We could have still reused that. So this is what it looked like. So I've still got to part this guy off. I'll part it off there on the area that we turn, and it should line right back up, and then we can make a good part out of that. So there's some more pieces right here. I've got these cut and deburred. I've already got them parted off because these were long too. Got them deburred, Now we're ready to go on to our machining right there. All right, this is ETD 150, which is a modified version of 4140. It has a higher tensile strength than your standard 4140. So really good, strong material for making parts like this. And these aren't under any kind of like high stress load. There is a little gear that you put on one side right there, and it goes into a servo motor, and it moves a little CNC machine around, from my understanding. I believe the machines are used to machine foam. I believe they cut out foam for things like this right here. If you want liners for your toolboxes, I think that's what they do. Obsolete parts that they can't find for the machine anymore, and that's why we're working on these. So I will say that this has been an excellent project to work on. This is my first real part that I have been working in Fusion 360, designing with the help of Kevin. He's been helping me with this, training me, and he was able to show me how to draw this up, sketch it, and then run it through the manufacturing process and then post it out so that we can machine it here on the Milltronics. I wanted to point out this little tip to you. Milltronics had pointed out a really good tip that anytime you're not actually running the machine, you can actually just hit the E-stop, which is what I've done. You can see the error code there. Whenever you're ready to use it, just simply enable it and it's ready to go. But the reason behind that is that whenever it's just sitting here in this position ready to machine, the weigh oil pump will continue to pump oil. I know this is timed, so I don't know what the cycle time is, but it's timed and it'll pump oil. So if you're not actually using the machine, you're wasting oil. So in order to stop it from doing that, if you're gonna walk away for any amount of time, just go ahead and hit the E-stop, and that disables the weigh oil pump and you're not wasting oil. So I've gotten a habit of doing it. Anytime I'm gonna walk away for any length of time, I just go ahead and push the E-stop, and then when we come back, just reset it, and then I'm saving a little bit of weigh oil there. All right, so I'm ready to get started on these. I think we have the machine ready to go, and these sizes I've been finishing these journals out, I mean, nearly spot on for what I'm wanting. And we're talking tenths, because those are bearing journals there, so those have got to be right. So I'll show you a little footage of the machining of these guys, and hopefully we can get this little batch knocked out, and we'll have a couple extras there. I'd like to keep one here so that I have a reference for later, but we've got 6, 7, 8, 9, 10. We need 8 of them, so we'll have 2 extra there on our hands. Okay, I stopped it there because I can tell that it's messed up again. I don't know if you can see that well, but it is pushing the material back in there again. So obviously I didn't tighten up the chuck quite right. All those little steps, it shouldn't be doing that. So if I leave it where it's at, instead of letting it finish, I should be able to save that and recut it and it be right. I've been running into this several times and I don't understand why it's doing it. I'm still trying to figure out why. So we've got it in hand wheel mode. Oh, rapid. I turned the rapid all the way down so we can get that back out of the way. Yeah, it's amazing how it continues to try to push that stock back. like it's doing with this 6-jaw, but it is. I try to get it to where it doesn't move around at just enough clearance to kind of slide around in there. Should be enough material to reface it again and clean up the back side. So, tighter that time. Okay, let's try it again. I think it's better this time. All right, there we go. I'm learning that on that chuck, man, if I just don't tighten it enough, it's pushing that material back. And that's even with a 10,000 feed rate and a 50 thou depth of cut. Let me do a real quick check here on our dimension, and it's looking good. I'm gonna do this one back here. That is looking good. All right, we got a good part there. So, go ahead and, this is why I had my soft blow hammer. Instead of using my hand, palm of my hand, I'm using that hammer just to loosen the chuck up. And we'll pull that out. And let's go in with another one. One of the problems is it's kind of an awkward position to tighten up a chuck right here. It's not like on a manual lathe where you can stand right over it and tighten it up. I'm at an angle, and then this wall back here kind of blocks me from being able to get a good pull on it. All right, let's run another one. I don't know if that'll mess us up, but I just stopped the spindle so I could come in here. That's another reason why I've been leaving the optional stop on the tool chains, is this kind of stuff right here. Gives me a chance to stop it if I need to. So just go ahead and enable the chuck again, and then it's like a start. All right, guys, we're looking good. All right, guys, so here's a failure for you. I'm sharing this with you. I was switching over to Finish Out Op 2, and I'm already messing up here. Good thing I've got a couple extras here. So you can see we've got some chatter in that turn. What I did was I pushed it all the way against the chuck jaws there, against that shoulder. And there's not a lot of area there to grab onto to hold. It faced it just fine, because I pre-faced it in the manual lathe to get it down so that I know that there was only 15 to 20 thou to take off of that. But when it came in to do the very first roughing pass is when it instantly had problems. You could see that the tool tried to dig in there, and as soon as it tried to dig in, it chipped the insert, so it was rubbing real bad. It was making all kind of noise. It really messed up that bearing journal there where it was chucked on. So that's not going to work. And I was afraid that this was going to happen, but I didn't know if it was going to work until I actually try it. So it's obvious that we need to support that with a center. I'm not set up on the CNC lathe here. I don't have any kind of tool set up to where it can come in and do a center. And I just don't think that it's worth it to me right now to try to set this up so that it faces it, it cuts a center, and then have to manually crank the tailstock up here to do this. And because of that, I might try two things here. I might go over to the manual lathe and go ahead and face them to the proper length. Go ahead and get the last bit faced off there and center drill them. And then be able to set them up in here and chuck on this, I forget what this is, 16.5 millimeter journal right there. Chuck it on that, support it with a center, and then turn it. But I just don't know. I'm kind of leery about messing another one up, so I may just end up doing that on the manual lathe. It won't take me long to do that either. But this is part of my learning process. I'm sure there's a lot of things that I could be doing better, and maybe some things that I should have already implemented on the machine. And that's where experience comes into play. I just don't have the experience on this. I know what needs to be done, but I just don't have the machine configured up yet, nor did I have the experience to program it so that it's facing it, cut a center in there, and then it has to stop, and I have to pull the center up here to it and then cut that way. I think I feel more comfortable right now just running parts up here, just sticking out of the chuck without the center coming up here. So this may end up just being finished up on the manual lathe. So I don't know. I'm kind of torn right now. And I don't know what I'm going to do yet, so I'll let you guys know what I ended up deciding to do on this. So I'm going to show you my process of what I'm doing to try to get these guys completed. What I've decided to do is come over here to the manual lathe, and I'm going to slide these guys in up to this bearing journal. This jaw right there has a sharp corner on it, so it's actually like provides a nice accurate stop there for me. I've already done two, and it's proven to work. So just barely loosened up so it still spins. Push it up gently, snug it up. Now I've got a 0 set over here on this dial. You can use the DRO. I just like looking at this dial indicator so that I can get the access of this faced off. And what this is doing is leaving 15 thousandths on there for my facing op on the CNC lathe. Now I know that you could do this in the CNC. I shouldn't have to do all this, but this is what's working for me right now because I'm able to just work through this. I'm wanting to get through this quickly and try to get these completed without spending a bunch of extra time or redesigning the program to work differently than what I've already designed it to do. So I'm just simply using the Precision Matthews here. Some of these still have, some of them have a little bit more to face off than others. And I don't want to take a big heavy cut on that face there. That's pretty good right there. And then what this does, like I said, this leaves 15 thou for the CNC to face off and turn it, and we'll hold it just like I've got right there. So we're going to be putting it in the CNC, and we'll chuck on this journal, and I've already proven that it actually works. I've been slowing my feed rate down so that you're not taking such a heavy cut there, and I've gotten 2 of them done. So I'm just checking it with my calipers here to make sure, yep, I'm where I need to be. So that jaw is actually working out. It's that bottom jaw there. I don't know why that one doesn't have a bevel on it. I never noticed it till today. I wanted to use a a vise stop in here, a jaw stop, and the diameter is too small for me to be able to use that, so I'm having to do it this way. So just push it in there until it stops. Snug it. Now that's a little bit heavier, so I'm going to back off about half of that. I just visually cut them off with a scale over in the saw, so they're not all the same exact length. Go back to our 0. I'm only doing 8 of these, so it's going really quick. If I had a lot of these to do, now we wouldn't be going through this. We would be using the CNC for everything. But this is working pretty good. I'm just checking it with my calipers here, making sure that we're good. And I'm just going to keep doing this. Only got a few of them left to do here. And then we'll go over to the CNC and do our turning operation on there. You don't want to take too big of a cut on that. All right. From here, we'll head over to the CNC, and I'll show you that second operation there. All right, back on the Miltronics. We're going to do the same thing with this jaw, or this chuck, I mean. We're going to be using that edge of the bevel, and I got it tightened up where I can just spin them in there until it just touches on that shoulder that we turned. Snug it up, and I've already done 2, so I know it's going to work, but like I said, on our roughing pass, what I've done is I've slowed the feed down so it doesn't feed so hard, and it seems to be working just fine. So I'll show you one of these being machined now. All right, so our roughing tool will take 15 thou off that face, do the rough turn, and then it'll make one pass for the finisher, just like the first side there. Slow it down as it approaches just to make sure it's all good. All right, now we don't have any crashes, right? It's working out good that way. It's kind of a little workaround on what I'm doing, I understand, but it's what's working for me to get this job done. You know, and I'm learning a lot as we go here. A lot of stuff that I'm figuring out on both programming, setups, running the Miltronics, a lot of different things that I'm picking up here. So, but like I said, that's working out pretty good right now. So I've still got 5 of them over here to do. I'm going to go ahead and finish out those other 5 and get all of our turning work completed. Okay, well, we've got 8 of our shafts now completely, all of the lathe work is now completed, and they all mic within the specs that they should be within, including our bearing journals there. I have these 2 right here that will actually probably be good shafts, but one of those is actually just very slightly undersized on a couple of the journals there. So these 2 right here, I'm going to be just keeping for myself. That one's got an undercut in it right there because I was actually using an older program to machine this, and I had, I believe I had cut it off and then remachined it, so it left that little undercut in there. Still a good part, but I'll keep it as my personal sample that I can reference later on. I've got like a bag with these parts that I keep tagged, and I know what they're for. But these 8 right here are supposed to be the spares for the customer. I've already made 2 of these. I made them manually and just got them sent up there because they were needing to get these guys installed on the machine and get it running again. And I wanted to use this as more practice, get back into Fusion 360 and practice learning how to sketch and draw in Fusion, and then use the manufacturing, the CAD, you know, and CAM to be able to machine these guys. And that's what I have successfully been doing there with this. And these guys have all turned out pretty good. They all look pretty good. And like I said, they all measure just like they're supposed to be. I gave myself some pretty tight tolerance to fall in. And what I ended up having to do was most all of these, I had to just barely polish these journals because you got 2 bearing journals there, and those need to fall usually within about a 1/2 thousandths. So I was hitting on the high side of the tolerance, and on some of them it actually finished a few tenths over. There was one that was about 5 tenths over. So I just went to the manual lathe and just did some polishing, and I used this mic right here to make sure that I was spot on my measurement. So I try to hit them on the high side of the tolerance there. So 8 good parts right there. We'll keep this one as a souvenir, as a failure, a crash, what not to do. And I know that going into this, you know, as I've been getting into this project, I know that there's better ways to do this, better work holding techniques. And I think what would work really well for parts like this right here is to actually have soft jaws in the lathe and bore the soft jaw so that this exact profile, you can stick it in there and the 3 jaws actually clamp down all the way to that shoulder there on that profile, and you've got as much rigidity as you can get. So that's one way that I can think about my approach in the future. But something else that I need to learn how to do on the lathe is a program for using a boring bar and doing ID turning there as well. But so these are all good. I was going to mention, this is one of my first ones that I was practicing on. This is just hot rolled 1 inch, and they were originally going to be longer. And my plan was to actually chuck this area here to be able to turn that. This was going to be, you know, a lot longer there, and that's what I was originally going to chuck on to turn that. And once these got shortened up, that kind of threw my plan out, and we went the way that we did. But we prevailed and we got it done. So anyway, from here we're going to be moving over to the Miltronic CNC mill, where I've got the 2 5mm keyways to put in here. I've already got my program written, posted out, and I'm going to be using these guys here, the ones that I would call bad shafts. I'm going to use these to make sure that our program is correct and that we hit the keyways milled in there in the proper location, my setup and all that kind of stuff. So that's what I'm going to go start working on now, and I'll fire it to camera when we know that we got a good program that's going to mill our keyways in the shafts.